I'm studying mechanical engineering and automotive. It's combined.
Nice.
I know cars really well.
Trevor hasn't joined in yet, but granted, I don't think he's online.
Let's just do it. He'll join if he joins.
He's got 15 minutes because we'll be done by then.
Yeah. Okay. Number 3, hypothesis tests consist of 2 hypotheses, the null hypothesis and the alternative hypothesis. Which one is the status quo? It's the null. Which hypothesis involves equality? It's the null. When computing the probability, which hypothesis do you assume to be true? The null. Which of the following represents the alternative hypothesis for a two-tailed test?
And that would be the mu is not equal to 10.
Yeah, because it's alternative. Okay. Which of the following represents the alternative hypothesis for a left-tailed test?
Which is mu is less than 10.
Is it that one or is it the... Wait, mu is less than, mu is greater than 10. I don't know, I might have been confused.
Actually in the book. But the way I remembered it is for a left tail, you're looking at where the alligator's tail is.
Oh, okay.
And for the right tail, because I just related it to mu, it's where the alligator's mouth is opening to, or which way his tail points. If that makes sense. So like in the left tail, mu is less than, but in a right tailed, mu is greater than, because his tail's facing away from mu.
Okay.
But if I could get the book to open, I can show you where it's at.
I have it open online if you want to find it.
Let's see.
Here's the mouse.
Right there.
Okay.
One-sided left tail, one-sided right tail.
Okay.
And that's so like the tail, because all the greater and less than symbols, all my life, my teachers always told me, like, remember the alligator's mouth, where it's opening to.
Yeah.
So for the tail, I figure Where's his tail at? That's his mouth. In relation to mu. And then the left tail, the tail faces mu, which is the left. And then the right tail,
So it's like where it's pointing to.
yeah. That's just how I remembered it. Just relative to that
Okay.
back piece.
Yeah, that makes sense. Okay. So I just got this confused. I was watching the video, and so it's a little easier to confuse it there.
I've never watched the videos.
I love the videos. It's like, whatever.
So on seven's left tail, yeah, and right tail.
Yeah. Okay. So, which relationship would result in failing to reject the null hypothesis? I said the p-value
Is what?
is less than a.
Isn't it the p-value greater than a? So I put p-values greater than a.
No.
What does the book say? P-value. Significance of a.
I think you're probably right.
Okay, we need a number that can be used to determine if the p-value is small enough to reject the null hypothesis. Oh yeah. If p is low, reject the null. So if a p-value is greater than a, you fail to reject the null hypothesis. If the p-value is less than a, then you reject the null hypothesis. It's all really confusing.
Okay, so if the p-value is less than a, then you reject the null.
Mm-hmm. Which would mean the opposite
So that's
would fail to reject.
right?
For 9.
Yeah. P-value.
So if the p-value is greater than a, you fail to reject the null hypothesis.
Oh, p-value is greater than a, then you fail to reject the null.
Mm-hmm. But if the p-value is less than a, like in 10, then you reject the null hypothesis.
P-value is less than a, then you reject it. P-value is greater than a, then you fail
Then you
to
fail
reject.
to-
Oh my gosh! So it's
I
just
know,
the wording
it's-
that screwed me up. Okay.
Yeah, it's really fancy wording for saying that the status quo is correct.
Yeah. Okay. 11. Which of the following would be the appropriate alternative hypothesis of H of A?
So an insurance company is reviewing its current policy rates when originally setting the rates. They believe the average claim amount was $1,500. They're concerned that the true value, the true mean, is actually higher than this.
So it'd be the average claim amount is greater than 1,500.
Because their null hypothesis is that the average claim is equal to 1,500.
Yeah, that's 12. Okay, the insurance company randomly selects n equals 40 claims and calculates a sample mean of x bar equals 1,650. The insurance company assumes the distribution of sample mean is normal. Is this a good assumption? Yes, because n is greater than 30.
Mhm.
What theorem or law justifies your answer to the previous question? Central limit theorem.
Yeah.
Which of the following is the test statistic as defined in this lesson? The z-score.
Mhm.
So z, okay. And that's as far as I got, so.
Yeah, let's see, I went through the whole thing, but I had questions on, 16, 17, 18, because they all relate to this.
Mhm.
He wants us to calculate the z-score, but it doesn't give us a standard deviation. Without that standard deviation, we can't use the formula we have to calculate a z-score. And technically, we don't learn about how to calculate your standard deviation without or how to calculate your z-score without a standard deviation for 2 more lessons. So I don't know if she wants us to look ahead or if it's just a
Yeah,
typo.
I got to this one too, and I was like, wait, what? So let's just read it all over again, maybe see if we can figure something out. The historical mean of sales receipts at a grocery store is $150, with standard deviation of $40. The store manager suspects that the average has decreased. She sets up a hypothesis test with the following hypotheses.
Look at that.
So we do have standard
We do have it.
deviation, okay? She will use a level of significance of 0.05. She then takes a simple random sample of 36 sales receipts from her store and computes. So we're using 150 minus 144 divided by
40 divided by the
40
square
divided by, how many did it say? 36.
36.
So 6.
Negative 0.9. So then we plug that into the,
Well, oh yeah, because we have to do that for 17.
what should we call it? Why can't they just,
BYU, Idaho, normal probability, yeah, but. Okay, I have it, negative 0.9, right?
yeah,
It's just the center, right?
what is the z-score?
But what is the p-values for 17?
Oh, I never put in the z-score.
So
So what is the p-value associated with the z-score?
are we just supposed to shade the middle on it? 0.632?
I think so.
Okay. What inference would you make about the null hypothesis for this problem? So the p-value is greater than the level of significance
Then alpha.
than alpha. So when
So
it's
then
greater than alpha, we,
fail to reject the null hypothesis.
okay,
When p is low, reject the null.
there you go. Right.
That's gonna stick with me right until the test. I'll forget.
P is low, reject the null. Okay, there are 2 types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true?
Type 1. Because there's also no.
There's that little chart thing. Aha, okay, here's that chart. So what did it say?
It says, what type of error involves rejecting the null hypothesis when the null hypothesis is true?
So null hypothesis is true, and you reject the null, it's type 1 error. Okay,
So a researcher decided that instead of using a level of significance of alpha equals 0.05, he will use alpha equals 0.01. Which of the following will be true? I put the probability of a type 2 error will increase.
yeah, because they're direct, yeah,
Inversely related.
nice.
Working on that for 2 hours,
Oh,
almost 2 hours. It's an hour and 45 minutes.
sounds like my chemistry homework.
I hated
Gosh, got 2 hours left.
What chem were you in?
I'm in 106 right now.
Oh, I'm sorry.
Yeah, so am I.
Automotive, but now I'm in engineering.
Well,
Taking ME 172, it's SolidWorks. Yeah. Very good design software.
Yeah, I don't envy you.
I don't envy you, so.
Yeah.
Each their own.
Yeah, that's very true.
So if A equals 0.05, compute the probability of committing a type 1 error.
Which is 0.05.
Beautiful thing.
Yeah,
I have to
it's the
take
same
my textbook in class,
For which one?
for my math class.
Oh, really?
I'm doing some class.
I had to take
I only
that.
need it for homework.
I had to take it every day. 9 in the morning.
Sucks.
It did.
I love how this room's got its own dedicated hotspot.
Yeah, it's nice.
It's fast.
All of the rooms have their own hotspots, don't they?
Yep, each apartment's got its own.
Then why does my internet suck so bad? Actually, I know why. It's because my roommates use it.
Yeah, if you roommates are using up a lot of the bandwidth, it'll slow down the connection.
Yeah,
Because it's one connection that's shared by
6 people.
however many devices, 6 people have connected to it.
Yeah.
You have 6
That's
guys in your
true
apartment,
because each one probably has 2 devices at
2 or
least.
3. I mean, I have 4 devices that connect to the Wi-Fi. Not at once. Like I have my
Yeah.
phone, I have my iPod, and I have my computer. Those are the 3 main ones.
Yeah.
And my PS3 is rarely connected to it.
Yeah.
Yeah.
A lot of devices. If you add it all up times 6 people, it's like
Or if
24
you're an
devices.
8-man.
Yeah.
If each person has 3,
That was me last semester.
if each person has 3 devices that connect to the Wi-Fi, and it's 6 people, that's 18 devices that are using bandwidth. So that's why it slows down so fast.
Yeah. See ya. Thanks for letting
Anyway,
us.
yeah, thanks for.
Oh, no problem. I mean, it's for everybody, so have fun doing homework.
Oh, we will.
Okay, do you just want to go over everything? Make sure we're good before we submit it? Okay. So 3, hypothesis contested 2, hypothesis. Which one represents status quo? Yeah, that's null. Involves equality, that's null. Computing the probability of hypothesis you seem to be true, and that's null. Which of the following represents the alternative for a 2-tailed tails not equal?
Left tail less than, right tail greater than. Fail to reject is P is greater than alpha. Reject the null is P is less than alpha. The alternative hypothesis in 11 is that it would be greater,
Yeah.
and the null is that it is equal to.
Yep.
It's normal because it's greater than any 30. Central limit theorem, because I don't think we've done law of total probability, and law of large numbers talks about the mean.
Yeah. Test statistic is the z-score. And what is the z-score associated with this test? So for that, we just
Oh, yeah.
plugged in the.
Don't forget to make sure you got 3 decimal places. Because, they really are sticklers for that.
Yeah. Okay, which p-value, so we just plug that in, and then what inference would you make about the null hypothesis? Fail. And there are 2 types. It's type 1, we looked that up. The probability of a type 2 error will increase. It's true.
And, okay, so I'll go first.
You sure?
It's supposed to be my turn last time.
Oh, got 1 wrong.
I wonder if it's the undershaded part.
That one?
Let's see. Where did we do normal probability?
Oh, yeah, he shaded the lower part in this.
Yeah.
I'm just looking over the video by clicking on it. Dang it. Although, oh, is it a one-tailed or a two-tailed?
Oh,
That's what matters.
is a good question.
What
This is a
problem?
left-tailed.
Left-tailed, so it's the under
16,
part.
yeah.
Oh, okay, so it's 0.184. What question did we get? Oh, this one.
Round was 17.
0.184.
And then everything else is good.